Problem-Solving Ability in the Procyon Lotor by Sabrina Gonzalez-Casteel, Sarah Mildren, and Adria Paulson. Laurel Moondream, the Executive Director of Medicine Mammals Rehabilitation Center, has been working with raccoons for over 40 years. Based on anecdotal observations, Laurel established a theory that raccoons with a greater number of tail rings display higher levels of intelligence. She told us stories about raccoons that had 8 tail rings being able to hold their own bottles when feeding. This, among several other observations over a 40-year time period, led Laurel to her theory. This theory is based on anecdotal information and is also based on the anthropomorphizing of raccoons. In order for this to be a testable theory, we had to eliminate the elements of anthropomorphism. We defined intelligence as the raccoon's ability to problem solve. When we tested this theory, we were able to calculate their ability by timing the raccoons during testing. We decided to test this anecdotal and anthropomorphized theory on the raccoons that are currently being rehabilitated at the center. Our research question was, is there a correlation between number of tail rings on the raccoon and their ability to problem solve? Our hypothesis was, yes, there is a correlation between number of tail rings and the ability to problem solve. We believed that the greater the number of tail rings on the raccoon, the greater their ability to problem solve. Raccoons have the capability of using their hands in a way similar to humans. Raccoons and humans are both pentadactyl creatures, meaning having 5 fingers. The raccoon can use their 5th digit in a similar way that humans can use theirs. Humans have a much wider range of motion. Raccoons can only move their thumbs from side to side. This is an ability that they take advantage of often when using a rolling motion. Because of the range of motion, we believed that the raccoons would be able to manipulate the boxes that we used to test their problem-solving ability.
We used continuous sampling of a focal animal for this experiment. Raccoons were filmed while they were in contact with the box, only touching it or the lock. They were timed upon review of the footage. We constructed 3 8-inch by 8-inch by 8-inch boxes with lids that would open and were locked with 3 different types of locking mechanisms. Inside the boxes, a marshmallow is hidden and the raccoons have to open the lock to retrieve it. Box 1 consisted of a sliding lock mechanism, had to be flipped up and then slid over. Box 2 was a clasp. You pull up on the tab and it would flip open the box. And box 3 consisted of a swivel hasp with a bolt and pin. The bolt and pin were not used. The boxes were placed inside of the cage with the raccoons. We were not able to isolate the raccoons from conspecifics, so there was some competition for the box. The raccoons normally investigated as soon as we put the box onto the floor of their cage. However, sometimes we did have to necessitate their attention towards the box, like here. Oftentimes, the raccoons would use a probing motion with their hands, as you can see female 1 feeling around the box and the lock. Other times, raccoons went for the brute force approach. This one right here bit around the edges of the box. This was one of the only raccoons that exhibited this aggressive of a behavior against the box. He literally chewed a corner of the box off, displaying this type of behavior. His approach was actually a little abnormal. This raccoon was a little bit more cautious, and that was a more normal response. He's using a digging motion with his front paws, attempting to separate the pieces of the box. A lot of times they also lifted the box, flipping it over, as you'll see in later footage. Isolation wasn't exactly possible. These 2 males actually did spend a lot of time working on a box together, the darker one on the right and the lighter one on top. They displayed more of a helping behavior rather than an aggressive behavior, something that was not seen in the female cage. The females were actually a little bit more aggressive about the box. This is once again another example of the probing behavior we saw. The females actually feeling around the lock. A lot of times they used their front nails to hook and lift the latch on this clasp lock. You can see her paws moving in a more touching motion, trying to feel it. She also displayed a lot of the picking up and flipping the box over as well. A lot of these raccoons also showed this type of behavior where they would prod at the lock, look at us, prod at the lock. They also did a lot of circling around the box and lifting up the sides, scratching at the sides, lifting it up, things like that, anything to try and get the box open. This is another really good example of how they used their nails and their probing behavior of patting on the box and the lock to try and figure out how it was supposed to move. Often they used their teeth. As you can see, this female is attempting to pull the box open just by the rope without undoing the lock first. These were our results. The graph on the left, the number of rings versus time to open box, showed a strong positive correlation. We calculated an R of 0.649. The graph on the right is tail length versus time to open the box, and there was no negligible correlation between the two. This is some of the footage of the raccoons opening the boxes. They often used their teeth to pull on the tail strings, or their nails that they would hook on their lock and flip the box open. These two females did actually show some assistive behavior. This wasn't very often. This was one of the few rare times that they had opened a box together in the female cage. This is the raccoon that was shown at the beginning that had bitten around the edges of the box. Eventually he realizes his mistake and flips the box lid open. Here it is important to note that for box 1, we had never slid the lock into the locked position. Here are the results for box 2, which was the clasp lock. As you can see, there is a weaker positive correlation between number of tail rings and time to open the box in the graph on the left, and still again negligible correlation between tail length and time to open the box from the graph on the right. This is an example of one of the mailboxes opening the hasp lock. They had to simply pull a tab and it flipped the lock open. They could then proceed to flip open the box. This is another female whose strategy to open box 1 was to flip the box over and then flip it back to get the lid open. You can see that she still tried to use the same strategy on the clasp lock as well. Unfortunately, none of the subjects were able to open the third box. This is one of the males attempting to open the swivel hasp. A lot of the raccoons got extremely aggressive with this box. They were unable to open the box, but not from lack of trying.
Although we had a strong positive correlation with box 1 and a weak positive correlation with box 2, we realized that the outcome of our hypothesis was the opposite of what we predicted in terms of number of tail rings. The less amount of rings a raccoon has on its tail was positively correlated with the fastest times it took to open each box. For example, the raccoons with only 5 rings were able to open the box faster than those with 6. This could be caused by a different variable that we didn't account for, such as physical fitness, gender, or even how hungry each individual was at the time. An issue that we encountered during the duration of our experiment was the fact that dominance seemed to play a huge role in which individuals were able to open the box. This created a bias towards certain individuals to continuously open the box. With the male's cage, they would continually fight over the box but work together to complete it. On the other hand, in the female's cage, female 1, who we named Mama, felt the urge to fight off any other female that attempted to open the box. This skewed the results by obtaining useful evidence from only a few individuals. Some issues that arose within the study were the lack of interest in the boxes from most individuals, which may have been due to the nervousness from being in close proximity to humans. Isolating the raccoons was next to impossible, and we seemed to be a distraction as well as their conspecifics and the upcoming spring season, which Davis believed to be something called instinctive drift, and that as spring approached, the raccoon's attention span became less than ideal. The problem-solving ability trait could have been learned by observing conspecifics. This is a scenario that we encountered while testing the males, who initially were unable to open the box, and then the female that was watching through the cage was able to complete the task right after. Another concern we had was that these particular raccoons have lived their entire life, which is about 10 months, in the rehabilitation center, and have never felt pressures to find food because it has always been given to them. This pressure could instigate wild raccoons to learn how to find ways to get food, for example, to get into trash, scavenge, or open doors. Without this pressure, these raccoons may have little concern with finding their way into the boxes. Even though they seem interested, their attention span is limited. In conclusion, our results showed the inverse of what we actually predicted. We did use a smaller sample size than planned due to aforementioned issues. Not all of the boxes were used the same number of times due to time constraints. In the future, we would like to repeat this experiment using infant raccoons and when time fully allows us to complete the study.
We'd like to thank Laura Moondream for giving us the idea and allowing us to use the Rehabilitation Center, Bill Scott for helping us build our boxes, and the raccoons for actually participating in the experiment when the mood hit them.